Alright, our dot products can be helpful also, these rules that we've been talking about, because they can help us find, we can find the angle between two vectors using the dot product. So my formula says if I want to know the angle between two vectors, the cosine of that angle is equal to the dot product of u and v over the magnitude of u times the magnitude of v. Now, of course, that doesn't tell us specifically the angle, it tells us cosine of the angle. But once I know cosine of the angle, I can do the arc cosine, or the inverse cosine, and figure out what that theta is. So let's look at our 2, -3, and we'll call that one u, and our v from the other page, which was 1, 5. And if I do a quick sketch here, okay, 2, -3 would be the vector that's going off in this direction, and that length. And 1, 5 would start here and go up like this. So not a super nice picture, but it looks like here this angle that they make is not an acute angle. It looks like it's bigger than 90 degrees, even from my very crude sketch. We know the cosine of that angle is going to be the dot product, which we found earlier on in the other video. If we needed a quick review on that, we take 2 times 1 plus -3 times 5. Okay. Now the magnitude of u, remember the magnitude of u is the square root of the x component squared plus the y component squared. And 4 plus 9 is 13, and that doesn't simplify at all. To find the magnitude of v, and this was the last section's videos that we did magnitude, I think. 1 squared plus 5 squared is the square root of 26. Okay. So -13 on top. If we put these guys together, a 13 gets to come out, and a 2 is stuck underneath. So we have -1 over the square root of 2 here, or negative square root of 2 over 2. Now, the happy accident is I just made these two vectors up before I started the video, and I didn't intend for them to be one of our special triangles, but in this case they were. Okay, if this was square root of 3 over 7, then we would need to use the inverse cosine button on our calculator and tell us. But I know that the cosine is equal to the square root of 2 over 2 at a 45-degree angle. Okay, now, if the cosine is a negative number, I know that happens in the second quadrant and the third quadrant, but with our inverse trig functions, we know that the cosine is negative. We're only looking at first and second quadrants. So in the second quadrant with a pi over 4 reference angle would be 3 pi over 4, or 135 degrees. So this angle between these two vectors, if I were to draw them nicely with a ruler or a graphing utility, they would make an angle of 135 degrees with each other. When we have two vectors, whoa, I'm off my page, that make a 90-degree angle, okay, we call those vectors orthogonal. Two vectors that make a 90-degree angle are called orthogonal. The nice thing, one way you can check, and you can figure it out right away, is we know that if we take the dot product of two vectors and get 0, then those vectors are orthogonal. Or if we're told that they're orthogonal, then we know that their dot product has to be 0. So if we look at any of these vectors that we had back on the first page, Okay, none of these vectors are perpendicular to each other. Okay, we know now that this angle is 135 degrees. We could go through, and if you wanted to, you could do that, but that's not part of the video that I'm creating just now. Okay, but two vectors are orthogonal if their dot product is 0. If their dot product is anything else, they are not orthogonal, but we could find that angle if we needed to know what it was. Now, I know that this video is kind of short, but I think to get the rest of what I say in there, it's going to make it way too long. So we're going to talk about projections in the next video, and how we can combine that idea with this idea of orthogonality to help us out with some physics problems.